Welcome. Thank you for joining our live webinar today. I'm your host and speaker, Martin Tetz, and I'm going to talk about accelerating multi-user database application performance with SQLBase. In using WebEx, I'd like to ask you to put your questions either into the chat tool or into the question tool that has the question mark on it. Both are available from your WebEx toolbar. And I might not be able to see all of your questions during the webinar, but I will answer them all at the end of the webinar for sure. So let's see what we are going to talk about today. Going to talk about the different SQL-based logging scenarios that you might encounter or that users might encounter. I will demo monitoring, logging, and cursor behavior using the SQL-based command center and some sample applications. I will demo resolving logging issues without changing applications at all. I will show you how to use Command Center to see if logging contention is a problem with your installation or with installations at your customers. Using Command Center to profile query performance is the kind of second part of this webinar, where I will show you how you find out what kind of queries are long-running and creating trouble for other users. And, of course, questions and answers, as I mentioned before. So let's talk a bit about SQL-based isolation levels and how they work. Cursor stability is kind of the oldest isolation level available for SQL-based. Cursor stability S-logs the current row page when reading. That means that cursors that want to update insert data need to wait until the S-logs are removed. This is an old terminal processing model where you have the current row of data on the screen, and this row is logged for possible updating. So this is not anymore the world we live in, really. I think SQL-based has released logs since many years now in a multi-user, internet, loosely coupled world. Release log actually makes a lot of more sense. This release log isolation level releases all S-logs when reading is done. You will find S-logs on indexes and data during select operations. So this is a modern way of using S-logs. Still, S-logs come in the way of other users, because if you have very long-running reports with very complex queries that do heavy joins, you might find lots of indexes being logged with S-logs. And that might hinder other users to update data, actually. With SQL-based 11, we actually introduced something new, which is called read committed, RC. So the name of this already kind of gives you a hint what that is. What we intend to do with this is give you the highest concurrency way of setting logs. In this isolation level, SQL-based reads data in read-only mode, so during reading there are never put any S-logs. So go back again. No S-logs ever means that everybody that wants to update data is not being blocked by people that read data. This isolation level also reads over X-logs from history data. So if somebody is in the process of updating data, you will be presented with the data before the update has been submitted to the database. And I think that makes a lot of sense. That's basically what all other databases do as well. And this helps you create a high concurrency applications. If you update data, this isolation level works actually in release log mode internally, which is nice to know, but nothing you have to care about, really. So what are the logging scenarios that you might be encountering in your applications, in your installations, deployments of SQL-based? Logging situations that bring down user performance perception when using release log or cursor stability isolation levels. There's one thing called when applications are waiting for an S-log to be removed for an update insert delete operation. And we will see that in a sample later. So if a really long-running query, a report that does very complex SQL processing, very complex SQL statements, this query in RL mode can put quite some S-logs onto the indexes, and people waiting for updating this data could have timeouts. So applications waiting for an X-log to be removed to continue data reading. So the other way around is that somebody has updated the data but not committed the update yet, and others want to read that data. And in RL, or cursor stability, this means people have to wait for the X-log to be removed before you can proceed reading this data. If the X-log is not being removed, then you are running into a timeout situation. So this all happens with CS and RL isolation levels. So how can you solve S-log contention? Basically, our suggestion is to use the read committed isolation level. If you read data in read committed, no logs are being set on data or indices. So this is basically invisible for others that you are working on the data, has no effect on others that want to read or update data. Other users can update data without running into log timeouts or without running into wait situations. Maybe the transaction takes like 10 seconds and your log timeout is set to 20 seconds, then they would wait for 10 seconds and then the reading process would proceed. Solving the X-log contention, again, actually pretty simple. Use the read committed isolation level. You will not encounter logs when reading data at all. When others are updating data, read committed isolation level reads through the history data and presents you with valid data anyway, because this data is still the committed data version that is available from the backend. So let's do a demo here. Use Command Center to monitor cursor isolation levels, TD applications to simulate and explain locking behavior. And this is the screenshot of the TD application that I'm going to use. So basically, the first thing I want to demo is, what happened in the past before read committed was there. And let me start SQL-based Command Center and go to the database level and check the cursor statistics tab. And you see there's one cursor connected in RL release logs mode. That's the cursor of the Command Center itself. Now, to provide a situation where readers get into the way of updaters, I do have a SQL talk script where I connect to Island. I actually set the isolation level to read repeatability. This means that all rows that I read will have S-logs. And that kind of simulates a locking situation. So now the whole company table should have an S-log on it. And now let me start the team developer application. And you see I can choose from several isolation levels here. Let me use release log and connect to the database. The connect worked, and I should be able to read data now because that is an S-log, so I can read data and browse through it. But if I press update now, for example, I want to update the city from München to Berlin, and I press the update button, then what really should happen is that I run in a log waiting situation and I should get a timeout. And the timeout should happen after 3-4 seconds because that's a timeout value that I have set. And here you can see the SQL error, which is timeout, transaction rolled back, and let me continue here. So this is where readers get in the way of writers. And now if I go back to the reading transaction and just do a rollback here, so there are no open S-logs on the company table anymore, I should be able to update, and the update, as you can see here, has gone through. And I can commit or roll back this. So this is the one situation where the reading transactions get in the way of updating transactions. Let me roll back this. And now the other situation is where updating transactions come in the way of reading transactions. Now I will open two of these applications here. Connect this one in release log as well. And now from the first one, I will again, so the city currently is München, and let me do that update. Now I have an open transaction here that has updated all the cities in the company table. And if I go here and do a select, I should get a wait timeout again. And the wait timeout actually somehow depends on your code. I've set it to 3 seconds, so I can get that pretty quickly, and you see that it happens here in this webinar quite quickly. So again, a timeout on the read operation, on the select, because somebody else has updated the data and not yet committed the data. I can again say continue, and yeah, get further errors. Okay, so and if I press rollback here, let's say, then I can do a select here, and that works. So you see, in release log still, there's these two ways where you can really get pretty badly in the way of each other. You know, the readers can block writers, and writers can block readers. Now, let me show you the same in different isolation levels, using different isolation levels. Start two instances of this application again. And one instance I leave in RL because that really doesn't matter, which I connect, I do a select, you see that here. And then I want to update that to Berlin again. And I do also this one here now I use read committed. RC1, I connect. I'm now connected, I can select, browse through the data, that works. And now I do the update here. So now I have an open transaction in this application here. There has not been a commit issued yet. If I do a select here, you see that I've updated the value for Berlin for the local transaction. But in this application, I do a commit and a select again, and you see I'm not running into any locking contention. I can also press this select loop, and you see the difference to before. Before, when I did an update, I could not read data. Now I can, and the select loop button here actually does executes 1,000 times select star from company, and if it's done, you know, you will see that we were not running into any locking during a pretty long read operation that has finished now. So using read committed allows you to read through data even when open transactions are available from other users. And also, let me again do the go here, do a rollback of these transactions, do a select again. So I have Munich in here again. And now let me do that select loop here again. Now this is running, select, select, select. And I do an update here and select. And you can see that all this worked while on the other side still the select loop is running. So these two applications are not coming in the way of each other, which is really very nice behavior, I would say. So here the long-running transactions has ended, and during the long-running transaction, I could still do an update on the data from this application here. So both situations where locking issues could have been present in the release log isolation level are not available anymore when you do use read committed. Okay, let me disconnect this guy here, close it, disconnect, close it, my little samples. And let's proceed with this demonstration here, with this webinar. Now let's talk about automatically solving lock contention. The good news is no need to modify your applications really. What you can do is edit your SQL.ini file of the database server in your dbntserv section and add these things here. AutoRC equals 1. This tells SQLbase that it should map release lock isolation levels to read committed isolation levels, which automatically resolves the locking situations for you. And default RC equals 3. This is the finest granularity of the history data that you would get. So this one makes sure that as quickly as possible you will see updated history data in RC isolation level when reading data. So these 2 lines of code, or these 2 lines in your SQL.ini file, will make your database fly if you have a lot of locking contention going on. So here's the demonstration. Changing application isolation levels without touching application source code. Now remember, I do have SQL console open. I think I still have that SQL talk session. Oh no, did I close it? Yeah. So the SQL talk is closed. Command Center is there. Let me close Command Center. And you see in Command Center there still is one cursor available. Let me refresh here. One cursor in release lock mode, which is the internal cursor that Command Center uses. Now let me close this. And let's go edit the SQL.ini file. I have prepared this here. You see it's in the program files, Unified SQLbase 11.6 SQL.ini. And in the dbnt srv section, I'm going to uncomment AutoRC equals 1 and default RC equals 3 and save this. So what I now have to do is stop SQLbase and bring it up again. And I do this from the task manager here. Services. Unified SQLbase. You see it's running here. And SQLbase doesn't run anymore. Oops. Start it again, because now the SQL.ini is changed and it should pick up the changed SQL.ini really. Close all this. And now SQLbase should actually change all isolation levels that come in as RL into RC. And we can actually use SQLbase Command Center to see if that is right. So here we go. Command Center restarted. Cursor statistics for the database. And you see actually even the Command Center cursor, which was RL, now is read committed, which is very nice actually. And now let's look at these applications again. Let's start 2 of them again. And I'm going to connect in the release lock mode here. So I'm using the old model. That is what your applications probably do. And I connect both in a release lock. And you will see from Command Center, both are connected and read committed, which is what I expected really. And now we can do that game again of locking. I'm going to, let me see, select the data. It's currently Berlin. I'm updating it here. So locally it's set to Munich again. And here I can still run a select loop without me running into any lock. So I can read the same data 1,000 times. And my reporting will proceed without running into any locking contention. And that is for you without touching the application at all. See, I'm in release lock mode. And if I look into Command Center, you see all the cursors are in read committed. So actually quite easy to do. Where's the slideshow here? So summary of locking contention. SQLbase 11.6 provides all you need to accelerate database performance quite a bit. No wait for XLock release during reading and reporting. No S-locks coming in the way of updates or deletes or inserts. isolation level read commit at RC, and you have automatic SQL.ini based conversion of release log to read committed. So if you experience some of these logging things and you think your multi-user performance is going down, then you should really have a look at this. And to help you find out what's going on, actually you can use Command Center, and that's what I will be showing you now. Use the Command Center for deadlock timeout profiling. Use the new auditing feature of SQL Base 11.6 Command Center to turn the auditing on server level. You select deadlocks and timeouts, and this is the window from which you do that. You see there's a checkbox on deadlocks timeout, and when you press Start Audit, then this will actually run during the normal operation of your server, and it will log all the deadlocks and timeouts you get into a log file, and you can then go ahead and analyze that log file. So if you switch on deadlock timeouts auditing, after some time you switch off auditing again. If you know that you're sure that the data you're looking for is present there, look at the audit log. Are there any timeouts or deadlocks? If yes, use the RC isolation as discussed in first part of the webinar. So if you see something like this, turn on RC isolation. Okay, let me just show you this. I did actually run such a log yesterday, and that is on the server level. You see that these audit options are here, and this is where you can switch on and off auditing. And I did a deadlock timeout and SQL performance and transaction performance logging yesterday quite extensively. And here's the audit results tab, shows the results of those. And from here on top, you can choose what data you want to see. I want to see deadlocks, timeouts, and you can see that I had quite a number of deadlocks, timeouts. So, and you also see what kind of SQL was executed for that deadlock and timeout, which is quite nice. And if you have lots of these, then go ahead and try the RC thing that I actually have switched on for this installation here. Performance profiling is the second part of the webinar, really. Use the new auditing feature for SQL performance and query performance. You turn that on server level. Select the SQL performance option there. This is how that window looks. You've seen that just before live in the Command Center. And it saves all the SQL statements and execution times to an audit log file. You can analyze the data via the Server Audit Results tab. You've seen that before. And it looks kind of this. There's a number of SQL statements there, and every SQL statement has the execution time with it in its own column. And if you click on a statement or on a line, then you can actually look at the execution plan and at the SQL of the table. And there you can see if, for example, for a long-running query, you don't have indices available, and you can create an index and then retry this, and so accelerate performance of your queries. You sort by execution time ascending. You look at the SQL statement. You check the execution plan. Are indices used as expected? Add missing indices, and test the performance again from SQL Talk if you like. Now let me show you that. Performance auditing. Detect a long-running query, analyze the query, create missing indices. Enjoy. So let me do that. Let's go to Command Center first and switch on auditing. I do want deadlocks, timeouts, SQL performance, and transaction performance. And with Start Audit, this is running now. And now let's go to a SQL Talk session that I have prepared, where I can actually run a bit longer running queries. Not too long running queries, but you see and then there's a count. That's the same one actually now. And now it does the same on the count. Now let's see if dropping an index makes any difference. And you see now, I actually should have dropped the index before I've done this presentation, but you saw that the count took much longer without the index. So that shall be our problematic query. So now I know that all the data I need to analyze what's going on is in Command Center, and I can go there and on the server level switch off the audit options, stop audit. And then the audit results, I now want to see SQL performance and not deadlocks. And you can see that July 12th is today at 17:25. That's right now. That was when the audit was stopped. And you see several the select count statements here. There's one that took 285 seconds, which is pretty long. And this one before is when when the index was present actually. Right now, if you look at it, it won't show you an index because the execution plan is evaluated right now at this time, and the index is not there. So if I go here, you will also note that it doesn't use any index, and that probably create an index will improve that situation. So now let's go back into SQL Talk and create that index. And if I now do the select count star, you see it's back immediately, which takes no time at all. So just creating one index has dramatically improved performance. And let me now go to execution plan. Oh yeah, and now you see that xcomp ID index has been used to calculate the amount of licenses in that query. So this is how you analyze query performance on your backend, and you see where problematic areas that you on yourself can improve by creating new indexes, by looking at what the engine does, how SQL statements are being executed, and this is a nice tool, Command Center, actually to improve your query performance, to find ways to improve your query performance. So we are in the question and answer part. Let me open the chat and QA tool. There's one question here. Can you explain the RC1, RC2, RC3 with an example? Actually, not today. I'm going to do that with the next webinar that we are going to do in August. Then we will talk about the exact details of what RC1, RC2, and RC3 means, and when you should see updated data in those modes. So come back for the next webinar to see this. If you have questions, put them into the Q&A chat. Well, looks like there are no more questions. You can always ask us directly by sending us an email at info@unify.com. If you need anything, you have a question, you want to know the pricing of anything, we will help you find out where you can buy our products, or you have a look at unify.com to find out what we're offering. Oh, actually, there's one more question. The new parameters, I assume those are the SQL NI parameters you refer to. Those are new in SQL Base 11.6. So the SQL NI things that I did show you are available in 11.6. In 11.0, you could actually set the isolation level via API calls. That meant you had to touch the application. With 11.6, you can use that automatic mode. Okay. I hope that answered your questions, and I'm looking forward to meeting all you again very soon. Thank you for attending this webinar, and have a good day, good evening, wherever you are in the world. Thank you and bye-bye.